Alright, so today we're going to talk about some more things about logarithms. We're going to start off with the properties, and I'm going to highlight the main property that you need to know. You're definitely going to know the first one, that the log of 1 is always going to be 0, okay? And the log of itself is always going to be 1, okay? You also need to know that if you have an exponent here, that exponent gets brought to the front and is multiplied to the logarithm, okay? Also, if you have two logarithms that are multiplied to each other, you can separate them by putting a plus in between them. And then the same with division, except for with a minus instead of a plus. So let's do some practice for that. Alright, it says find the exact value using the logarithmic properties. Since this has an exponent, I can take this exponent and move it to the front. So it's going to be negative 5 times the log base 3 of 3. With this log function, since I have a base with the same number, that's going to come out as 1. So it's going to be negative 5 times 1, which gives me the logarithm of negative 5. Okay, we're going to talk more about the ln, but the same principles here. So move this 6 to the front, so it's 6 times the ln of e. And we're going to talk more about this, but the ln of e is 1. Okay, so it's really 6 times 1, which is 6. Okay, on this one, since I have this subtraction here, that means I can write it as 1 logarithm. So it's the log base 3. When it's subtraction, you do the first one divided by the second one. Well, that's just 3. You do 21 divided by 7. And anything with the same base is the number 1. Okay. On these ones, we're going to use the property to expand these out to multiple. Okay. Here I have 10x, that means multiplication, so I'm going to do log of 10 plus the log of x. On this one, first thing I got to do is this division. Division means subtraction, so it's ln of xy minus the ln of z. Okay, but this xy is still being multiplied, that means plus, so it's the ln of x plus the ln of y minus the ln of z. Okay. On the flip side, we're going to condense them on these ones. Okay, that's subtraction, that means division, so it's the log of the first divided by the second, so it's the log of 7 over x. This one we're going to go left to right, so we're going to do these two first. You have plus, that means you're going to add them, so it's log base 2 of 5, or multiply them, of 5x, minus the log base 2 of 3. Okay, now we have subtraction, so we're going to get log base 2 of 5x over 3. And now it's 1 logarithm, we're good to go. Okay. Got it? So we have some kind of logarithms that are in base 10. Base 10. These are called the common logarithms. We use base 10 number systems so that we frequently reuse these. If sometimes you won't see a number, so there's an imaginary 10 there as your base. Okay? So it says find the exact value of each logarithm. So with these, the log button is the button on the calculator, so I'm going to change this from standard to scientific. Okay? And how we do this, we just type in the number, 1,000, and then hit the word log. And it tells me log of 1,000 here would be 3. Okay? Well, first in this one, we're going to do square root of 100, so we're taking the log of 10. Okay, so if we type in 10 log, we know that our answer would be 1. Okay? So finally, the approximate value here onto the nearest 10, so let's do the log of 5. 5 log, nearest 10th would be 0.7, 1 decimal place. Okay? The log of 101 is 2.0, we do 2 decimal places. 2.0, we do 1 decimal place there. That's it, logarithms are that simple in this, you just do them in the calculator. Sometimes the natural events that occur in the real world are often called with, okay, the natural logarithms. Okay, so natural is that ln that we were talking about earlier. They have a base of e, which is Euler's number, which is approximately equal to 2.7183. Okay, so log base e meets the ln of x, and we have the ln button here, and we do these the same way. That's the nearest thousand in these cases, so 3 decimal places. So you do 5 ln, and this one will be 1.609. Okay, the ln of 101, so L101 ln would be 4.615. Okay. In some situations, we need to approximate a value for a logarithm that is not base 10 or base e. So like the ones we did on the last, yesterday, there's a formula that can help us get the exact number of those logarithms. It's called the change of base formula. And what it basically says is I can take the log of the big number and divide it by the log of the base. Okay, same with the ln, same situation. So let's try it. Okay, so let's use logarithms to help find the exponential. So I need to convert this to a logarithm function. So remember, it's log base of the exponential, so base 4 of 5 is equal to x. Well, to do that, I can do the log of the big number, which is log of 5, divided by the log of the small number, which is of the subscript, which is log of 4. And how do we get this? So in my calculator, I'm going to hit 5 log divided by 4 log. Okay, equals, and I get that x is approximately 1.161. We'll do 3 decimal places. 1.161. Okay, so I'm going to do another one. Okay, so this is going to be log base 3 of 2 is going to equal y. So again, you change your base because it's not a base of 10, so it's log of 2 divided by log of 3. So let's set it in. So it's 2 log divided by 3 log equals 0.631. So y is approximately 0.631. Okay? Logarithms are very helpful when solving real-world problems. Okay? Recall the formula for compound interest. A equals P times 1 plus R over N to the NT. A represents the future, P is initial, R is the rate, N is the number of times that we're compounding per year, T represents the time series. So it's how long will it take $2,500 to double if it is invested at 5% interest compounded monthly? Okay, so we know A says that it's going to double, so that's going to be 5,000 equals our principal, which was 2,500, times 1 plus our rate at 5%, which is 0.05 over our N. Our N is compounded monthly, so that means 12 times a year, okay, to the NT, which would be 12T. T is what we're solving for. So first thing I got to do is I got to divide by this 2,500. So I got to get rid of that. So I get 2 is equal to 1 plus 0.05 over 12 to the 12T. Okay? So we're going to do 0.05 divided by 12. First, gives us that. We're going to add 1 to it. So we're going to have 2 is equal to 1.0041666 repeating for 12T. Okay, we're going to convert this, so it's really saying it's the log of that number. So second equals 12T. Okay? So it's going to be, we're going to change the base. So it's going to be log of 2 divided by the log of that number. Okay, so we're going to do that first. So log 2 divided by the 1.00416666 repeating the log. Okay. It equals, and I get that number, 166.7. Okay. Okay? And then we still have to solve for t, so we got to divide that number by 12. And we get approximately 13.89 is equal to t. Alright, let's do another one. DDT is a pesticide that was banned in the 1970s. One of the reasons was due to its toxicity to aquatic life. The following formula, y equals I so E of negative 0.0046 times T. Okay. Approximately how many years it would take 50 grams, so our initial was 50, okay, I is initial, so it's going to be 50 E to the negative 0.0046 T. Get decaying down to 1, so our future is 1. Okay, and the first thing I do, divide by 50, divide by 50. Okay, see that, 1 divided by 50. 0.02, so it's 0.02 is equal to E negative 0.0046T. Since we have a base of E here, since we have a base of E, let's take the natural log, okay, when we're converting it. So remember, we do log base E of 0.02 is equal to negative 0.0046T. A log base E is the same as the natural log of 0.02. So let's do that. Negative 0.02, take the natural log of it, we get that number. But then we got to divide it by what's in front of T, which is 0.0046 negative. And we get that T is approximately 850.44. Okay? The formula to determine the concentration of hydrogen ions in a substance is given by H plus. So H plus is equal to 10 to the negative pH. Okay? H plus is the amount of hydrogen ions. pH is the acidity level. Human blood has 3.6 times 10 to the negative 8 hydrogen ions. Okay. 3.6 is the same as 0.003456. It's 7 zeros, so to know how many zeros you put in front of the decimal, you just take 1 off of the exponent. Okay, we're going to convert it because our variable's in the exponent, so that's how we know we convert it. So it's going to be log base of the exponential, which is 10, of 0.00456736. Okay, since it's a base of 10, that's what our calculator is, so we're just going to type in that number. 1, 2, 3, 4, 5, 6, 7. Okay, get logs, and we get that our acidity level is negative 7.44. Okay, but since there's a negative in front of the pH, we're going to divide both sides by negative 1. So 7.44 is our human blood acidity level. Okay, Newton's law of cooling states that the rate of change in the temperature of an object is proportional to the difference between the temperature of the object and the temperature of its surrounding. Okay, the function T of T is equal to 70 plus 130 e to the negative 0.0486 T. Okay, describe the temperature of coffee heated to 200 Kelvin and now cooling at room temperature. So it's asking when will it get to 105. So 105 is going to be our future. So that's our T of T there. Okay, we're going to subtract the 70 first. And which gives me 35. uncertainty on both sides to get that decimal. I know since that's the base of E that I'm going to have to take the natural log, so I'm just going to hit ln. I get this number. And then I'm going to have to divide by the number that's in front of t. And I get that t is approximately 26.99, which rounds out to 27.